good afternoon, or morning, or evening, or whenever you're watching this. Alright, so today's lesson is on absolute value equations, solving them, and solving absolute value inequalities. And we only have one objective here. That's very sweet. Makes for a pretty short, to the point lesson. Okay, so that's what we're doing. We're solving and graphing absolute value equations and inequalities. And this is just one variable. Just have an x in them. Not x and y, just x's in them. And then there, of course, you can see your assignment, and I want you to do it in both set builder and interval notation to get practice in both of those, just like last time. So start us off with the picture that goes with our objective here about being able to solve absolute value, solve and graph absolute value equations and inequalities. And I'll let you just kind of take it in and wondering what the heck is going on in that picture and what it has to do with absolute value. And I'll tell you, but not just yet. Let's look at this exercise first. So Kenny digs a hole in his backyard while his parents are still at work. He neatly piles the dirt from the hole on the concrete patio. When Kenny's parents return home, they demand that Kenny explain why he destroyed their well-manicured backyard oasis. Well, Kenny explains that the hole and the dirt from the hole demonstrate absolute value. What the heck is Kenny talking about? So now let's go back to the picture. So this picture is doing exactly what Kenny was trying to explain to his teachers. That if you take the amount from the hole and you place it in the patio, now let's just kind of assume that he places it in exactly the same like shape as the hole. Well, you can view the ground as being 0, and the amount out of the hole, your pile, is the positive number, and the amount inside the hole, that's the negative number, and these things have the same absolute value. In other words, they have the same distance away from the ground. And so that hole can demonstrate absolute value together with all the dirt that came out of it. Huh? Isn't that clever? Okay. So absolute value, that's what we're talking about in this lesson. So the technical definition of absolute value right there in blue, absolute value of a number is just simply its distance away from 0 on a real number line. So this over here right beside it is your first exposure, I think, of what is called a piecewise function. It's like an equation, but it has different pieces to it. So for example, if I'm looking at the absolute value of x, if that's what I want to evaluate, I evaluate it just depends on what x is. If x is already a positive number, then I just get x back. So for example, if I wanted to find the absolute value of 6, it's just 6. I get 6 back because 6 was already positive. Okay, so if I take the absolute value of 0, that's the middle one. If x is equal to 0, then I just get 0 back. Well, you might go, well, why didn't I just use that same exact rule? Tell me, why couldn't I use that same exact rule for 0? That's right, 0 is not positive and it's not negative. It's neither one of those. It's special. Okay, and then finally, if x is already negative, then I have to take the negative of it. So for example, if I take the absolute value of negative 25, I need to take the negative of negative 25. The opposite of negative 25 is positive 25. Of course, what this is pretty much saying is that absolute value is always a positive number. Right? Right? And that's usually how we think of absolute value. Just whatever it is, just make the number positive. Okay. So graphically and in terms of an equation, this is how we interpret it. So look at the top line here. Over on the left-hand side. Let's look on the left-hand side first with just the one with a red 0 in it. So if I'm talking about the absolute value of x, realize that what you could also think of that as is x minus 0, the absolute value of x minus 0, because we're finding the distance away from 0. That's what it means, the distance away from 0. If I take, like for example, in geometry, when you're measuring stuff, what you usually did is you took the 0 and you lined it up on one end of a segment, and then you took like however long the segment was and you found that number. You didn't have to subtract, it was just 5 inches, say. But that would be the same thing as 5 minus 0. Now what would you do if instead, like, the first ½ inch of your ruler was broken off? Because, you know, sometimes how you put it in your notebook and, like, the top of it breaks off. Well, what you could do is you could start measuring from the 1, and this time it goes to 6. That doesn't mean it's the segment, whatever it is 6 inches long. It's 6 minus 1, and now you've just found the distance away from the number 1. And that's what's taking place over here on the right-hand side. So look at the equation there. It says x minus b in the absolute value. That means the distance away from b instead of the distance away from 0. Okay? And in either case is equal to some number k. So k and b, they're just numbers that they just made up, whatever they are. They're just showing us in general what that's supposed to mean. Okay, so let's look at the graph right across the middle. And maybe I'll throw some numbers in here so that it might make a little bit more sense to you. Okay, so let's just say, for example, I say the absolute value of x is equal to 3. So down here on the graph, what this is saying is that this k value is 3 to the right, so my it could be the number 3, or k to the left, in which case it would be negative 3. Okay, to the left and to the right. All right, let's look over here on the right-hand side. If I say the absolute value of x minus 2 is equal to 3, now I'm talking about the distance away from the number 2. Let's say that b is equal to 2 there. Okay, so now I need to go 3 to the right of that. That's 2, where I'm starting at, plus 3. That would make this whole quantity equal to 5, right? Or 2, and to the left 3, I would take away the 3, and that would be at negative 1. And that's exactly how I'm supposed to solve each one of these equations. Now I'm going to summarize it for you in just a minute so that you can just go look at it and go, oh, I'm supposed to do this and I'm supposed to do that, and that's all I have to worry about. Okay? So basically, we're looking for two solutions. Look right down below on the left-hand side. I would set it equal, x is equal to the positive k and x is equal to the negative k. Okay, on the right-hand side, I do exactly the same thing, but this time I have a little bit more stuff inside the absolute value brackets. I would set it equal to a positive k and set it equal to a negative k and solve both of those equations individually. So here is that. Well, let's practice it. Let's see how this thing works out. Okay, we'll do these two together. First one should be very super simple. If the absolute value of x is equal to 15, what does x have to be? Well, obviously, x could be equal to 15, right? Because its absolute value is 15. Or x could be equal to negative 15, because both of those have a distance of 15 away from what number? 0. And I know it's 0 because there's nothing else in there. That's as if someone had written x minus 0 inside there. Okay, so that's our answer. Just those two numbers. Okay, let's look at the second one. The absolute value of 2x minus 9 equals 15. So essentially what this is saying is that the distance between a quantity 2x and 9 is 15. So I solve it. I need two answers. I solve it like this. 2x minus 9 is equal to the positive 15, or the 2x minus 9 is equal to the negative 15. Just draw a line here and separate it and solve it the two different equations. Let's add the 9 over to the other side, so I'd get 2x is equal to 24, and divide, so x is equal to 12. There's one answer. And then over here on the other side, again add it over. This time 2x is equal to negative 6 when I add the 9 over, and x is negative 3. Now if I were to stick either one of those back into the original equation, it would be just fine. So just let's look at it. So for example, if I stick in 12, I would have 2 times 12 minus 9. Let's close those parentheses, and I want to take the absolute value of that. I'd have 24 minus 9, absolute value of that. 24 minus 9 is absolute value of 15, which is 15. So that checks out. All right, so let's check the second one, the negative 3. So 2 times negative 3, someone's running down the hall, minus 9, absolute value of all that. It sounds like a couple of somebodies are running down the hall. I would have a negative 6 minus 9 in the absolute value brackets, negative 15 when I add those two up, which the absolute value is just 15, and it also checks out. Okay, so let's summarize
that right here. And by summarize it, I mean, let me give you an why did it, this is the, it's the same. I don't know what happened here.
This is the slide I was looking for. Here you go. So here's the summary. Whenever you go to solve an absolute value equation like this, you're essentially solving two equations. You set it equal to the positive answer and you set it equal to the negative answer, and you just solve those two equations separately. Finally, number 3, you're going to stick those answers back into the original inequality to see if they work. Because as you'll see in just a little bit, sometimes they don't. Okay, sometimes they don't. You stick it back in there and then the absolute value messes everything up, and well, you'll just have to see, right? Right now you're probably going, why wouldn't it work? I just solved it. But you know, sometimes it doesn't. So here are 2 of them for you to try on your own. Maybe something crazy will happen, maybe. I don't know. So pause it for me and give those 2 exercises a try. All right, let's see what you came up with, shall we? Here we go. So on number 1, nothing out of the ordinary happened. You solve 4x plus 12 equals a positive 28, and 4x, or I should say, or 4x plus 12 is equal to negative 28. Both of those, solve them down. The first one gives you 4. The second one gives you negative 10. If you go back and check them, as you can see in blue right there, they both check out just fine. Now, what I will mention, of course, is that whenever you go to check it, you want to check it back in the original equation, not the 2 that you break it up into, the original absolute value equation. Okay, on the second one, if you didn't check it, you probably didn't realize that something tricky happened. Okay, so you set number 2 up as 2 different equations. The 4x plus 10 equals a positive 6x, and then the one that's equal to a negative 6x. Solve them both down. You can get answers for both of them. For the first one, you get x equals 5. Plug it back in, it works out fine. For the second one, you get x equals negative 1. Okay, when you stick it back in, on the left-hand side of the equation, you can see it checks out. It gives you 6. But on the right-hand side, if I take 6 times negative 1, it makes it equal to negative 6. And the absolute value of 6 is always a positive number, so it can't ever equal to negative 1. And that's a contradiction. If that's the case, we have to throw that one away. This is what is called an extraneous solution. So in the course of solving an absolute value equation, if you get an answer that, like, you solved it correctly, right? Whenever I look back at my work on the other one, I didn't make any mistake. You solve it correctly, but when you stick it back into the original equation, it doesn't work anymore. This happens with absolute value equations, and you'll see it'll sometimes work with say quadratic equations. So this is something from here on out that, hey, I could solve something, but that answer may not actually work. It's extraneous, and throw it away, get rid of it, put it in the bin. Okay. All right, so in the second part of this, we're going to look at absolute value inequalities instead. All right, so look for that video next.